Hi, I'm Joe James, and in this video I'm going to explain primitive data types in Java. A variable in Java is nothing more than a reserved memory space to store a piece of data in it. And there are two general types of data in Java. There are primitive types, and within primitive types there are 8 different types that I'll go into explain in detail in a few seconds. The other type is object or reference type. And anytime you instantiate a class, let's say dog or person, you create a new instance of a dog. That is an object or a reference type variable. So expressing primitives, integral types, there are 4: byte, short, int, and long. These are basically non-floating point type numeric variables. And they can be expressed as either octal, decimal, which is the default. Most of the time you're going to express them as just decimal numbers, or hexadecimal. And when you're expressing a number as an octal or a hexadecimal, you use either the prefix 0 or 0x. So as you can see my examples here, we declared a new octal number using the 0 prefix before the number, and a new hexadecimal number using 0x prefix before the number. And if you have no prefix, as we do in this middle one, you're just creating a decimal number. There are 2 floating point data types in Java: float and double. And they can also be expressed in scientific notation. Now most of the time when you're declaring a float or a double, you will just say float pi, or your variable name, equals 3.14. You're going to say the value in decimal notation. But you're also able to use the scientific notation by adding the letter E after your floating point value. So here 6.02 E23 is equivalent to 6.02 times 10 to the 23rd power. And double gravity equals 6.674 E minus 11. That's equivalent to saying times 10 to the negative 11th power. So it's very easy to create scientific notation variables using DE. So the 8 primitive data types, I already explained that byte, short, int, and long are all integral types, meaning they're non-floating point. And you can see that they range from 8-bit to 16-bit to 32-bit to 64-bit. And the range of possible values, of course, gets substantially larger. Bytes and shorts are commonly used for when you have a large number of variables and you want to save memory. So you can use a byte or a short to save memory if you have a small range of values and you have a whole bunch of values. And int and long are great for higher precision values. In the floating point, we have float and double. Float is a single precision floating point number, and double is a double precision or 64-bit floating point number. And you can see the range of possible values is pretty great for float and doubles. Boolean is really just a flag. It's a single bit variable. It's either true or false. And char is a Unicode character, and it takes up 16 bits in memory. And this also tells you what the default value is. The default value for any new variables created is always 0 or false in Java. For instantiating new primitive variables, you do not use the new keyword. If you're familiar with Java, you'll know that you always use the new keyword when you're instantiating new variables, as we've done here in the bottom part. Person, Bob equals new person. So you use that to tell Java that this is a new variable that you're instantiating. But when instantiating a primitive type, you do not use the new keyword. So int age equals 25, double pi equals 3.14. So each primitive data type has a corresponding object or reference type in Java, which is nothing but a wrapper class for the primitive type. The primitive type uses a lowercase letter, but the object type in most cases is exactly the same word, just with a uppercase starting letter. So you can see byte corresponds to byte, short corresponds to short. This object type is a reference type variable, and this is a primitive type variable. And Java knows to convert between those, and this is called autoboxing. Java will automatically convert between a primitive and object type when needed. So if you have a, let's say, integer where you need an int, Java will almost always convert for you between an integer and an int. Now we recommend that you explicitly cast a variable to whatever you're trying to change it to. but in most cases Java will correctly cast it for you if you're trying to convert between these primitive and object types. So object types also have access to a number of different methods that primitive types don't, most especially for converting to and from strings. So in this case we have a 5, we're passing in the string 5 to the parseInt function of the integer class, which is returning the int 5. And it also enables them to be used as generic types where an object is required. For example, if you need a generic type integer, you're not able to use an int where you need a generic type because an int is not an object. So that concludes my video on primitive data types. I hope you found this helpful. If so, please give me the thumbs up and subscribe to my channel. I'm Joe James. Thanks for watching.